Hey there, Mrs McTaggart here, and we're doing a video on differentiation at higher level again, and we're going to be talking about increasing and decreasing functions. So to check if a function is increasing or decreasing at a given point, you have to check what you get when you do your derivative. So just a reminder of the three scenarios. If your derivative is greater than 0, it means that your function is increasing. If it equals 0 exactly, it means it's stationary. It's a bit like a tangent to a curve. And if your differential is negative, then it means that your gradient is decreasing. And I've illustrated it here on 3 little diagrams. My curves have gone a little bit wonky, but I'm sure you'll forgive me for that one. Okay, so differentiating can help us decide if a function is decreasing or increasing at a given point, okay? Or we can actually, further down the route, we can look at doing a thing called a nature table and find the shape of the function by simply looking at the derivative. Okay, so question 1. State whether this function is increasing, decreasing or stationary when x equals 2. So the minute you hear these words, increasing, decreasing functions, it's a buzzword to differentiate. So we're going to differentiate f of x, and it will give us 6x squared, take away 3. So a nice short derivative. They're told us when x is 2, so we're going to plug in the value of 2. And we'll have 6 times 2 squared, take away 3, which is 6 times 4, 24, take away 3 is 21. So we've come out with a scenario that f of x, well really it's f of 2 we're using, is greater than 0. So this means the function is increasing at this point. So I'm just going to write f of x is increasing when x equals 2. So remember, if that had come out as less than 0, I would have said decreasing, and if it come out as 0, I would have said that it was stationary. Okay, question 2. When is f of x increasing or decreasing? So this one's a little bit different. Now, once you've done stationary points, there is another way of doing this. You can do it by a thing called a nature table, but we're not going to do that today. We're going to do this one using the quadratic inequalities. So first off, increasing, decreasing functions, buzzword for differentiate. So let's differentiate and see what we get. This will give us 3x squared, take away 2x, take away 1. Okay, now we want to know what f dashed x looks like here. So f dashed x is actually giving us a quadratic. Now this is a smiley face quadratic, and what we're going to do is we're going to go find our roots for this quadratic. So we're going to do, for the roots, you put your quadratic equal to 0. And you factorise. So numbers can only be 1 and 1, and that's going to be minus there and plus there, giving us x equals minus 1/3 and x equals 1. So on my picture, I can now put the roots on that this is minus 1/3 and this is 1. So the question says, when is it increasing or decreasing? So remember the scenario at the very first slide with all the 3 diagrams. It was increasing when f dashed x was positive. Okay. And looking at our picture, f dashed x is positive here and here. Is this ringing a bell? It's a quadratic inequality. So it's increasing at those 2 points. Now remember, that's the 2 points go opposite directions, so anything before a negative 1/3, so x is less than negative 1/3, and anything after the number 1 and x was bigger than 1. Now it's decreasing when f dashed x was negative, which means that is the bit below. So it's decreasing here. F dashed x is negative at any of these points. So that's anything trapped between negative 1/3 and 1. And then if you forget which way the arrows go, my wee mantra was always, what would Beyonce say? And Beyonce would say, to the left, to the left. And although it hasn't asked it, it would be stationary when f dashed x was equal to 0. And that would be here at your roots. So it's stationary when x equals minus 1/3 and x equals 1. And that's a lovely lead into the next lesson, which will be stationary points. But for now, that's what they're looking for. When is it increasing or decreasing? So come back to your quadratic inequalities. Number 3, we have to show that this function is always increasing. Now, always increasing can also be spun the other way as never decreasing, okay? And they could ask you either scenario, but they both are the same thing. So if you're always going up, it means you're never going down. Think of it that way. So to show that it's always increasing or decreasing, so buzzwords, f dash x, let's see what we get. So f dash x would give me 3x squared, take away 12x, oops-a-daisy, plus 12. Okay, now if I was going to go try and factorise this thing, I would take out a little common factor of 3, x squared minus 4x plus 4. And that would give me x minus 2, x minus 2. Right, so I've got a repeated root here, which means that I have, if I was to do my discriminant, this would be equal to 0. And because I've got a repeated root, it means I've got one point of contact. And in fact, if I was to draw this a bit like the quadratic inequalities, I would have a smiley face with a root at 2. And remember, this is your graph of f dash x. Now, from that graph is never below. It's never negative. So what we can say is that f dash x is greater than 0 for all values of x. Therefore, f of x is is always increasing. Because your derivative is always greater than 0, your graph is always increasing. Alright, so never decreasing, and watch the way they spin that. And that's me talked about increasing and decreasing functions. The next bit will be stationary points, which will give you an alternative way to do some of these questions. Hope this has helped, and thanks for watching.